Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, I can't talk today, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So we're going to go on and look at section 6.6 today, but before we do that, are there any questions from over the weekend, section 6.4? If there are, bring them on. All righty, I guess we'll go on to 6.6. So section 6.6 doesn't really have anything new in it. It's just sort of a summary of all that we've done in this chapter. So let's see, we've taken out the greatest common factor. We've factored by grouping. We've factored trinomials that had a leading coefficient of a 1. We've factored trinomials that had a leading coefficient other than a 1. We've factored trinomials that were perfect squares. We've factored binomials that were the difference of two squares. So now they're just going to kind of dump it all in there together, and then we're going to go through a process to deal with each of these. So what I want to do right now is write down a list that I use to sort of a checklist to go through and deal with factoring polynomials. Okay, so I'm going to write this list out, and it starts like this. Item number 0.5, which I know is a strange place to start, but I will explain. 0.5 says standard form. So that's where you have the variable in descending powers. Okay. Let's see. Step 1 is take out the GCF, that is greatest common factor. Step 2 is for binomials, and we want to look for the difference of two squares. Step 3 is trinomials, and we're going to have a Roman numeral 1, which is perfect squares. Roman numeral 2, which is x squared plus bx plus c. That's where the leading coefficient is a 1. And we factor it like that using the product and the sum. 3 is ax squared plus bx plus c, where we use grouping, that is a, b, c, p, s, or trial and check. And then 4 over here is factor by grouping. 5 is RU through, and 6 is check your work. Okay, I'm going to refer back to this list as I go through and give examples of polynomials and how this works. Now, why did I start with 0.5 instead of 1? Well, because that makes things work nicer, because binomials have 2 terms, trinomials have 3 terms. Typically, when we factor by grouping, there's 4 terms. The greatest common factor, you're taking one thing out. That's why I did it that way. Okay. All right. So let's take a look at a problem. Let's see. 8m squared n cubed minus 24m n to the 4th. I just remembered my mistake. I want to go back here. There's one thing I want to do, and that is this. This whole idea of standard form is for trinomials and everything above that, okay? With a binomial, we want to leave it or put it in a form where it's something minus something. We want to have a subtraction sign in the middle of those two terms if we can. That's more important than standard form when we're dealing with a binomial. Okay, and that'll come up here. So this is a binomial, but the first thing I want to do before I see if it's the difference of two squares is to take out the greatest common factor. Well, let's see, that would be 8m n cubed. So my leftovers would be m minus 3n. And that's all I can do. What's left over there is not the difference of two squares. So that's our final answer. Any question about that? Okay, let's take a look at another problem. T minus 90 plus t squared. This is a trinomial, so standard form is important. So we'll rearrange it in standard form. T squared minus 90t plus, oh, excuse me, my bad. That's not 90t, that's a plus sign, isn't it? Yeah, okay. So let's see here. This would be t squared plus t minus 90. My t's, I'm going to put little tails on them. All right. So now I have a trinomial in standard form. There's no greatest common factor to be removed. The leading term has a coefficient of 1, and it's not a perfect square because even though t squared is a square, 90 is not a square. Since it has a leading coefficient of a 1, I'm going to break it up like this. Then I'm looking for a product that's negative 90 and a sum that's a positive 1. The implied 1 coefficient in front of the t. So I'm looking for two numbers whose product is negative 90 and whose sum is 1. Since the product is negative, we have to have a positive and a negative. Since the sum is positive, the positive has to be slightly larger than the negative. So how about 10 and negative 9? So plus 10 minus 9. Can we do anything further? Well, this is a binomial. 9 is a perfect square, but t is not a square, so that's as far as we can go. To check our work, we'd multiply things back together. T squared minus 9t plus 10t minus 90, t squared plus t minus 90, and it checks. So this is correct. Any questions on that problem? Okay, let's see here. AB squared minus 4a plus 3b squared minus 12. Here we have 4 terms, so factoring by grouping comes to mind. But first, is there a greatest common factor I can take out of all 4 terms other than just a 1? It doesn't appear to be so. So I'll split it up into 2 groups of 2. Let's see, the greatest common factor of the first 2 terms is a with a leftover of b squared minus 4. So for that to work, I have to have b squared minus 4 as the leftovers on the right side. And I would have a plus 3 outside. So that would give me b squared minus 4 times the quantity a plus 3. But then the question is, are we through? No, we're not, because b squared minus 4 is the difference of 2 squares. That could be written as b the quantity squared minus 2 the quantity squared. So this becomes b plus 2 times b minus 2 times a plus 3. Now we're through. Any questions there? Okay, let's see here. And if I'm going too fast, let me know. If I need to slow down for you to write things down, please tell me. 16 minus 40z plus 25z squared. This is a trinomial, so standard form is important. 25z squared minus 40z plus 16. There's no greatest common factor. The leading coefficient is not a 1, but better yet, it looks like it might be a perfect square. The leading term is a perfect square, the last term is a perfect square, and there's a plus sign. If that is the case, we'd have to take 25z squared and break it apart as 5z and 5z, 16 and break it apart as 4 and 4. Since it's minus 40z in the middle, it would have to be minus. Does that give me minus 40z in the middle? Yes, it does. So there's the answer. Or we could write it as the quantity 5z minus 4 squared. Okay, let's see here. How about this one? A squared plus 8a plus 3. This is a trinomial. It's in standard form. There's no greatest common factor. It has a leading coefficient of a 1. It's not a perfect square, but since it has a leading coefficient of a 1, it would break apart like that. The product would be 3, the sum would be 8. And again, I'm going down this list in terms of checking things off. If you need me to put that back up there again at any time, let me know. Product is 3, sum is 8. Well, to get a product of 3, we have to have a positive times a positive or a negative times a negative. But for the sum to be positive, the two factors of the product would have to be positive. Well, 3 and 1 is the only possibility, and that doesn't work. So this is prime. It doesn't factor. Let's see here. We have 28 minus 3m minus m squared. This is a trinomial. It's not in standard form, so let's put it in standard form. Negative n squared minus 3m plus 28. It has a leading coefficient that's a negative 1, so I'm going to factor out that negative, which changes the sign of each term inside the parentheses. What I've got left isn't a perfect square, but it does have a leading coefficient of a 1. So I'll split up the leading term as an m and an m. Now my product is negative 28 and the sum is 3. So I need a positive and a negative factor. Adding them together, I get a positive sum. So the positive factor has to be larger. So 28 and negative 1, that doesn't do it. 14 and negative 2, that doesn't do it. 7 and negative 4, there we go. That has a product of negative 28 and a sum of 3. So I've got plus 7 and minus 4. All right, well, unless you stop me, I'll just keep continuing with examples. Let's see here. 70 p to the 4th power q to the 3rd power minus 35 p to the 4th q to the 2nd power plus 49 p to the 5th q to the 2nd power. Well, this is a trinomial. Standard form looks a little bit tricky. Let's take out the greatest common factor and then go from there. Oh, I can take out a 7 out of 30, out of 70 and 35 and 49. I can take out p to the fourth and q squared. So that will leave me with 10q minus 5 plus 7p. Well, 10q minus 5 plus 7p isn't going to factor any further. So let me clean that up a little bit. So there's the final answer. Let's see here. How about this one? 81 r to the fourth power. 81 r to the fourth power minus 256. Well, let's see. Is there a greatest common factor? Well, 81 is 9 times 9, or 3 times 3 times 3 times 3. 256. Remember, if you add up the digits of a number, which would be 13, if 3 goes into that number evenly, 3 goes into that number to the original number. It doesn't appear, though, so I don't think we can take out a greatest common factor. But let's see here. Let's go back here and let's erase this to give me some room to write. Can I write this as the difference of two squares? Well, 81 would be 9 squared. R squared to the R squared would be r to the fourth. Is 256 a square? Well, let's see. I'm going to take 256 on my calculator and take the square. Oh, yeah, it is. It's 16 squared. So that means I have 9r squared plus 16 times 9r squared minus 16. Well, the first binomial factor, 9r squared plus 16, that's the sum of two squares, but it's not the difference of two squares. So that won't factor any further. But the second factor, the 9r squared minus 16, that could be written as 3r the quantity squared minus 4 the quantity squared. So this comes down, and this gets split up into 3r plus 4, 3r minus 4. Well, again, we have a binomial factor. It has a subtraction sign, so it is a difference. 4 is a square, but 3r is not a square. So there's our final answer. We can't go any further than that. Okay, let's see here. Here we have 12x squared plus 14x minus 6. This is a trinomial in standard form. It has a greatest common factor of a 2, so that leaves us with 6x squared plus 7x minus 3. So then I want to see if 6x squared plus 7x minus 3 factors further. I'm going to factor it using the grouping method. Let's see. So then A would be 6, B would be 7, and C would be negative 3. The product would be A times C, which is negative 18, and the sum is B, which is 7. So how about 9 and negative 2? That would give me a product of negative 18 and a sum of 7. So then I'm going to have 2 times 6x squared plus 9x minus 2x minus 3. I'm going to use factoring by grouping. So 2 times. Greatest common factor of the first two terms inside would be 3x. So I have a 2x plus 3, a 2x plus 3, and a minus 1 outside. So I get 2 times 2x plus 3 times 3x minus 1. The most common mistake students make with this is they take that 2 out and then they don't remember to drag it along and have it as part of the final answer. So be careful with that. Would you like me to do this problem using the trial and check method? Anybody? All right, then I won't. I'll move on. Let's see here. How about this one? AE plus BF plus AF plus BE. Well, this is 4 terms. There's no greatest common factor I can take out of all 4 terms, but I'm going to use grouping. So I'll break it down into groups of 2. Well, there really isn't a greatest common factor in the first 2 terms other than a 1. What if I rearrange the terms? What if I wrote them as AE plus AF plus BF plus BE? So I'm just going to switch those 2 terms around. Let's see what that would do. Well, now I've got A times E plus F. So over here, I'd have to have E plus F. Does that work? Well, it does, but I've got the BF in front of the BE, don't I? I suppose for it to work out really nicely to start with, I'd have AE plus AF plus BE plus BF. When I do that, I get A times E plus F plus B times E plus F. So I get E plus F times A plus B. So sometimes you have to commute those terms around to get it to work out nicely for factoring by grouping. Okay, here's another one. 6x squared minus x minus 16. Well, that is a trinomial. It's in standard form. It doesn't have a greatest common factor. It's not a perfect square, is it? And it doesn't have a leading coefficient of a 1. So A is 6, B is -1, and C is -16. The product is -96, and the sum is -1. The num, that would be me. So I'm looking for 2 numbers whose product is negative, so it has to be a positive and a negative, and whose sum is -1. So that means we're looking for 2 numbers, one positive, one negative. The negative has a slightly larger absolute value, only slightly larger by 1. There's a couple of ways I could approach this problem, okay? One method would be to start at the outer edges and say, well, it's got to have a negative that's larger than the positive. So I could choose those to start with. That would give me a sum of -95. That's not going to work. Oh, but -96 is even. I could cut that in half and make it -48. So then I double the 1 and get 2. That gives me a product of -96. And the sum is going to be -46. So I'm getting warmer. I could split -48 in half and double the 2. That would be -20. I could split that in half and double that. That's -4. I could split that in half and double that. That's going to give me a +10. But I'm looking for a -1, which is somewhere in there. Let's see. What else could I do? I could also go -16 and +6, which would give me -10, wouldn't it? But that would kind of go up in there, wouldn't it? So I'm looking for some numbers, one of which is between here and one of which is between there. Well, between -12 and -6, there's what? -7, -8, -9, -10, -11. So that's 5 numbers. Between 8 and 16, there's more than 5 numbers. So is there a number between -12 and -6 that goes into -96? Let's see, -7, -8, -9, -10, -11. Well, -7 doesn't go in evenly. -9 doesn't go in evenly. -10 doesn't go in evenly, and -11 doesn't. How about -8? Well, if we use -8, it would go with 12. That gives us a sum of 4. My conclusion is that this thing is prime. Okay. Any questions about that problem? All right. Let's see here. Done that one. How about this? X cubed minus 25. Is that the difference of two squares? Nope. It's the difference of a cube and a square. There's no greatest common factor I can take out. So that's prime. How about this one? 16d squared minus 56dz plus 49z squared. This is a trinomial in standard form. Let's see. I don't think there's a greatest common factor. It looks like it starts with a square and ends with a square, and there's a plus sign. So let's see if it's a perfect square trinomial. That would be 4d and 4d and 7z and 7z, but it would have to be minus in the middle. That's minus 28zd or dz, minus 28dz, minus 28dz plus minus 28dz is minus 56dz. So it works. You could write it that way, or 4d minus 7z, the quantity squared. Okay. Let's take a look at some that are a little bit trickier. How about this one? X to the 6th minus 4x cubed minus 12. Well, that is a trinomial. It's in standard form, descending powers of the variable. It doesn't have a greatest common factor. It's not a perfect square, and it has a leading coefficient of a 1. So we would break that up x cubed, okay? And then we've got to have a product that's -12 and a sum that's -4. How about -6 and 2? Now, neither of those are the difference of two squares or the difference of or sum of two cubes. We skipped that part, but they aren't. So this thing is the final answer. Okay. How about this one? 25b squared plus 14b plus 49 25ths. Well, we've got a fraction there. We can't clear the fraction because this isn't an equation, so we have to live with it. This is a trinomial. There's no greatest common factor. Oh, 25b squared is a perfect square. How about 49 over 25? 49 is a square. 25 is a square, so 49 over 25 would be, what, 7/2, the quantity squared? So, let's see here. 5b, 7/5. I said 7/2, I meant 7/5. 7/5 plus sign, plus sign. Well, that would give us 25b squared. That would give us 49 over 25. But what about the middle? Well, 7/5 times 5b plus 5b times 7/5 would give us 7b plus 7b, which is 14b. So it checks. Or again, we could write it 5b plus 7/5, the quantity squared. Okay. One more. Let's say we've got 1/4 minus u squared over 81. Well, this is a binomial with a subtraction sign. Let's see, can we write it this way? Well, 1/4 would be 1 squared over 2 squared, or 1/2 squared. U squared over 81 would be U squared over 9 squared. So U over 9 squared. So we get 1/2 plus U over 9. Let me write that a little better. 1/2 plus U over 9 times 1/2 minus U over 9. So that is the difference of 2 squares. Okay. I said one more, but I lied. I've got even another one I want to do. Sorry about that. X to the 4th minus 13x squared plus 36. Well, this is a trinomial. It's in standard form. It starts with a square and it ends with a square, and there's a plus sign there. So let's see if this works out. This would be what? 6 and 6 minus and minus. That would give us the first and last term, but there's a problem because we don't get minus 13x squared in the middle. We get minus 12x squared in the middle. So it's not a perfect square, but it does have a leading coefficient of a 1. So we could split it up, x squared and x squared. The product is 36 and the sum is negative 13. How about negative 9 and negative 4? So we get negative 9, negative 4. That works. That gives us x to the 4th up front, plus 36 at the rear, and minus 9x squared plus negative 4x squared, which is negative 13x squared in the middle. But wait, there's more, because this is the difference of 2 squares, x plus 3 times x minus 3. And that is also the difference of 2 squares, x plus 2, x minus 2. So wow, that's like a math teacher's dream. It has a little bit of everything there, I guess. Maybe not a student's dream, but all righty. I think I've tormented you enough for today. Do you have any questions before we quit for the day? All righty. Well, I will be back at 1:15 with an office hour. I'm going to go ahead and stop the recording now.